So now we have this. What we are trying to do is we can just simply say what proportion of these species are present in a collection of phylogenies and what proportion are absent, and we can look for, say, families which have a large proportion of things absent, and these are relatively where we should be focusing our efforts. These are where the large part of the Darwinian shortfall exists. Certainly the phylogeny database is the main challenge. So i.e. we need to compile. So here we have 3 phylogenies. Now we can't use images, that's very complicated. What we need are machine readable trees. These are simple text-based format which can be read by a simple computer program. So we need a machine readable tree corresponding to this, also one for this, also one for this. And we need a lot more than 3. We need to sample phylogenetic progress for the insects, so let's aim for about say 1000. So we know from earlier studies that most studies do not provide a machine readable tree with their publication. Some do, so we're going to have 2 different challenges. So this study has provided a machine readable tree. We need to process that. So that's one. And the second thing is, if it hasn't, for those which haven't, then we need to have some way to transcribe from the images. So firstly, the processing of machine readable trees. Very briefly, we get these from primarily data repositories like Dryad and Figshare. And these all need to be processed. I've even made a lot of videos on this already. You can see these, all of these are videos about a specific machine readable tree which I processed, so you can get some idea about what's involved. But very briefly, so maybe faced with something like this when we download, and certainly during the review process, reviewers will look at images, they'll look at the text and the figures, they won't look at the machine readable tree. So the standards are a lot lower for the formatting of machine readable trees compared to the figures which are sort of formatted better. So there's a lot of things we have to deal with, and so we have 2 terminals probably from the same species, and they are both numbered. So the authors will have to put a number after them. If they don't, many software will crash when faced with duplicated IDs. So that's why these are here. But generally, if we are aiming for a species level phylogeny for the insects, presumably, and so actually we want to remove one of these. If we counted the number of terminals, this wouldn't correspond to how many species in this tree. The most obvious case being this one is duplicated. So firstly, we need to remove any numbers which are, and here's a regular expression. This is a simplified bit of code which will scan all the terminals for a particular pattern, a word, underscore word, and a number. And here's a match for the number here, which has been omitted from the replacement here. So it just retains this. So that will create this. And now this is the generally a format we need. Going back to the taxonomy here, well, here you can see the format. Species identifiers are comprised of the 2 components, genus and species. So that's what we created here. But we have other things. This is, I don't know, maybe geographic code or higher taxon, abbreviated family name, something like this. At least this is identifiable. The others have used all uppercase, and it's a standard, say 4 character length. I'm going to underscore And this is more recognizable as a binomial, so we need to trim this off, and we're left with binomial. There's a regular expression for this. And we have some, this is not really the correct way to do this, but this is a problem with a lack of scrutiny for machine readable trees. You will get various idiosyncrasies to deal with. So I have a genus name underscore and just a number. Formula, even if you wanted to number that, you should have Celomorpho underscore SB underscore and then something after that. But anyway, we need to remove the number, and here's the regular expression, which will look for genus name underscore number and replace the number effectively with a SP. And we have also a notice. This is also common. This is always for a subset. Now, if subspecies names were universally added, then we could consider incorporating it in the book. But it's not. It's always a minority, so it's not really usable. This needs removing also. So we have various processing of the individual terminals. Now we also have to process the set of terminals because some of these are uninformative. We've already seen this one here. This is a species duplicate. Now, so when we consider the terminal set here, this goes through a filtering process to create this. Now let's see why some of these choices have been made. Vitifera, diva, species duplicate here. We need to remove one of these, and you can see we have this. This is think of this as the framework for, whatever our taxonomy of insects, and we're trying to figure out what we have. This is sort of formalized a framework, and we're trying to correspond these. So Vitifera diva here, one species unit. We have a congena, fine, this goes here. Now here we have a Pterolophia SP, so SP means it's species has not been assigned. So we know from our taxonomy we have two species, but we don't know which one it is, so let's put it at the internal node corresponding to the genus. And also note we have Nemoria NR arena, so this means something like near. It's probably this species. There's several others, AFF, and several more here, encounter. So it's a arbitrary choice what to deal with. Personally, I also Open Tree of Life they will assume this is correct. I think this is a reasonable choice. So in this case, I would just remove the NR, assume this is okay, just due to the scale of our challenge, and so that will go here, and we have Cleora subcincta, obviously goes here, and Bryoptera SP. We don't know what species it is, so it goes at the genus node. And also this is important here, so Celomorpha tropica, which is here, fine, but we also have something from the same genus without a species assigned. This is very, very common. Now, bear in mind, we're trying to assess how many species are in this thing, and we don't have the information to determine this could be the same thing or not. So we need to be conservative. So that needs to be removed, and we're just left with Celomorpha tropicola. So I call these species ambiguous congeners, and these are removed. There can be a lot of them, but we just don't have the information to assign them to species, and they, as I say, they could be the same thing anyway. We wouldn't know that, so that needs to be removed. So this is a processing step for Each machine readable tree is one other thing I'll point out. This is unfortunately very common. Now, I've said now a couple of times the species IDs are comprised of genus and species. It seems like a common, seems like a simple thing to say, but we are often faced with this. Taxonomists will abbreviate genus names, so we are no longer faced with unique species IDs, which is so we can't actually directly attach them to a broader database. So we need to deal with this common problem and figure out, in some cases it just adds a whole lot of steps. We need to figure out what genera these refer to, and even make say make a table and replace the ambiguated IDs with the full species IDs, something like this. Okay, so that's the machine readable trees, and then we've got the 75% of phylogenies, roughly, which do not provide machine readable trees. You've actually got to manually transcribe that. This is rather laborious and not particularly interesting job that he's doing. But it's one odd thing. Yeah, I mean, it is what it is. You can just transcribe this. You can use the software to assist. There's not really been a report of a reliable software which will do the whole thing. Mainly considering the wide variety of plotting phylogeny plots and the information which can go on there. But anyway, you can just if it's a modestly sized phylogeny, it's actually not too bad, not too much work to manually transcribe. It takes about the same time as processing the machine readable tree. But certainly it becomes more difficult for very large ones. But just to say, yeah, this is the manual transcription is just the manually assigning to a set of nested parentheses like this, and again, there's always some uninformative, taxonomically uninformative terminal sets which need to be removed. Species repeats, species ambiguous, congolars, higher taxon terminals, and so on. Each a single processed standardized machine readable tree from 1,000 studies, i.e. one tree per studies, so also 1,000 studies. And here they all are. There's in this image I've simply plotted 1,000 insect phylogenies onto a single image. Immediately you can see this interesting distribution where you have very few very large phylogenies published in insects, very few numbering above several thousand, and very few numbering into the tens of thousands. So a lot of scope for synthesis work in the insects.